Hey all you cool cats and kittens. So for this video we are going to be doing a little bit more of a challenging problem. This is going to cover a bunch of steps, so this is a really good practice problem. It's from chapter 5 and it's for Chem 101 or anybody that wants to join in. What we're going to be doing is we're going to be calculating the mass needed of a solute if I'm given the volume and the concentration. So this is from the homework. It's number 57 part B, because I think it's a little bit more difficult than part A. But it asks me, what is the mass in grams needed to make 245 milliliters of 0.30 molarity potassium dichromate? Wow, that's a lot of stuff to do, right? So let's define what molarity means first. Molarity, capital M, equals moles per liter, right? So first off, I notice that I have molarity and I have milliliter, so that's kind of odd, and I can rearrange this equation, can't I? If I need mass in grams, what can I actually do? If I find mole, I can turn that into mass, can't I? So this is probably my first goal. If I find mole, I could turn it into mass. How? Using the periodic table. So this is going to be a side quest we're going to have to do. So I'm going to find find moles first, then I'm going to find mass. All right. So let's find out how to solve this for moles. So if I were to multiply both sides by liter, I would be left with, we have multiplied both sides by liters, we would be having a capital L times M, which is our liters, times our molarity would equal mole. So that's another way we're going to rearrange it. So liters times molarity would equal mole. Okay, well, do I know liters? Sort of. I know milliliters. Do I know molarity? Yes. And do I know mole? That's what we're going to solve for. So liters, we're going to have to turn this into liters. How? 245 milliliters, put it over 1. And I know that 1,000 milliliters is equal to 1 liter. Milliliters will cancel out, and I'll be left with liters. So essentially, you're dividing it by 1,000, right? So this is going to be 0.245 liters. Nice. So now I have this, and I have this. I can now solve for mole. So mole is going to equal liters, 0.245 liters times molarity, which is 0.300, and I just like to write moles per liter because isn't that what capital M means, molarity? What's going to happen to the liters? Remember, anything is over 1. Liters will cancel out. So I'm going to type this in my calculator. I'm going to have 0.245 times 0.3, I get 0.0735. 735, yeah, that's what I said. 0.0735 moles of potassium dichromate. So moles of K2CrO4. Nice. Or no, potassium chromate, not potassium dichromate. What am I thinking? So I need to now turn moles into mass. How can I do that? You need molecular mass. So now I'm going to turn, I need to have the molar mass of this though, don't I? Which would be in units of grams per mole. And my final unit is grams. That's my goal. So let's find the molar mass of this. So for K2CrO4, that's going to be 2 times whatever K weighs. So I have my periodic table right here. Potassium has a weight of 39.098. One of the chromiums, which has a weight of 51.996. And 4 times, and we all know oxygen, it's 15,999. All right, so I'm going to type that in my calculator. Let's move this all up. There we go. So 2 times 39.098 plus 51.996 plus parentheses 4 times 15.999 and parentheses enter. It has a molar mass of 194.188 grams per mole, right? So if you want a whole mole of potassium chromate, you're going to need 194 grams of it, right? Okay. But from our problem, it looks like we're going to need much, much less than 1 mole, correct? So our mass should be much, much, much less than 194. So we need 0.0735 moles. Put it over 1. And I know that 194 grams is equal to 1 mole. So I'm going to use this as my conversion factor in my stoichiometry. Am I going to put moles on top or on bottom? On bottom, right? Because I need the moles to cancel out. So 1 mole is equal to 194.188 grams. So what happens to the moles? They cancel out. And I just need to multiply these two numbers. So I already have the molar mass in my calculator. So I'm just going to multiply that by 0.0735. I get a mass of 14.27 grams. Wow. So that is the final answer. So let's go back and look just for 1 second. The big question was, how many grams is needed to make 245 milliliters of this certain concentration? So my first goal is to find moles. And how do I do that? I manipulate the equation here. Liters times molarity is moles. So I did liters times molarity. Oh, sorry. We converted it to liters first. Then I did liters times molarity, and we found that we need 0.0735 moles. So to go from moles to grams, you use the molar masses from the periodic table. But since this is a compound, I have to actually multiply 2 Ks plus a Cr plus 4 oxygens. I did just that, and I found that this is the molar mass. So if I am given, or I need 0.0735 moles, I know that for every 1 mole you need 194 grams. I multiplied those out and I got a 14. So I do hope that this helps. This is very good to practice, and this covered a lot of stuff, right? It covered not only molarity, it covered conversions from liters to milliliters to liters, and it also covered calculating molecular weight using the periodic table. So this is a very good practice.